Okay, so let's talk about the gRPC. We already understand about RPC. RPC allow us to make a remote uh, any function, any method, any procedure, any service, or any code executions. That means one machine can want to execute a particular run the code, particular method, particular function. RPC allow. So the same RPC concept the implemented by the Google that is known as a gRPC. Okay. So gRPC is also a form of your RPC communication that meet a remote procedure call. Remote procedure calls. The gRPC is a very high performance RPC framework that allow developer can build scalable and efficient API. So gRPC help us we can develop API. What do you mean API? API is a kind of a what I say API is a kind of service. So let's say this is my server. This is my server. A server have a written very good a particular function, particular method, particular logic that can serve a specific function. So these methods surely can call by anyone locally on this my system. Any function, local method, different classes, different object they can call. But is it possible not this function can be accessed by the other machine, other server, other client, remote location? So we as a service provider, as a function provider, we want to expose, we want to tell, hey, anyone in the world on the internet, anyone can get the benefit of this particular function, particular methods. So those expose particular method or function or services to the third party, to the client, to the other server. It's known as a API, Application Programming Interface. That means another client can communicate via this endpoint or this end API. You can say API or endpoint or function that's known as API. So gRPC help us. We can develop the gRPC API. gRPC API was this concept was developed by Google and is now widely used in the production environment. In the case of microservice environments, lots of services are we are building, and many services can require inter-service communication between the services. Might be directly our client, our UI application or front-end application directly not communicate to the other microservices, but somehow we one microservice call to another microservice, microservice call to another microservice. Yeah, they want to get data, they want to exchange data. So in this scenario, the inter microservice communication required. That where this gRPC play a very good and a smooth role. Okay, so here like one microservice, they are going to the call another microservice, just look like a they are calling simple one function or one method that look like the local. So from the very easy simplified communication between the two nodes, two server, two devices, for the developer point of view, for the programmer point of view, the gRPC make a simplified of the remote procedure call. So these are the some basic concept in the gRPC. Uh, one is the very important is the service definition. Here, let's say this is a microservice one, this is microservice two. This is the microservice one, and this is microservice two. So how microservice one know which function or which method I am going to call? What are the set of API or set of function you have to expose remotely for the client? So due to that, we need some standard document communication so that this client or maybe other microservice, another microservice, all microservice, how know this specific microservice, which of a specific function they have exposed as API for other machines. So service definition give one standard specific documentation for the all service or API consumer. So this first in the case of your gRPC API, first and primary objective of the defining our service contract. So it is a like a not a standard document, but it is a known as a protobuf file or dot protobuf file to define the service interface and the structure of data exchange between the client and server. So in this protobuf file, I'm going to show some sample where we are going to define a standard service name or API name, service name, API name. So we have write one document that is known as a protobuf file where you define all my services name or API name and each service, what are the request data structure and what are the response data structure would be. This profile can be used by many clients to know the detail about the input, output, and service name. With the help of this service definition, maybe client, maybe server can generate the stub. Notice the whenever we learn understand about the RPC communication, application to application communication happen that require the stub, client stub and server stub. So from how client stub generated or server stub generated, that's this documentation, this protobuf file using the protobuf compiler, we can convert your service stub. Maybe service stub can generate the code that provide the interface to the client to remote method call. So this first we have defined the protobuf file. This protobuf file service name request response, and we are going to using the protobuf compiler. Protobuf compiler generated some set of classes for us, whatever the language it is. And this remote and this client going to our client code are going to just call this method, and these methods are internally what kind of a request parameter, what kind of response parameter, everything are going to well. So from the client, whatever the client they have, they need this protobuf file to compile and generate all the stub classes, and from the client code they are just calling simple function or method look like a local function call, and everything is whatever the how happen how intercommunication between microservice happen, that is taken care by your gRPC framework or gRPC runtime environment. And in this also, like this is the gRPC API is the form of RPC. So as standard, we required one client, we required one server, and again marshaling and unmarshaling runtime environment. Because finally, whatever the our client, and this is my server, okay, this is my server. So here finally communication happen on the internet, okay, via the particular protocol. So they are using the transport layer protocol where the communication happen, what kind of data they are going to transfer here, because the particular request response object cannot understand by the my network our channel. So we have to go into Marshal, means we change our request method, procedure, and input parameter the particular format that can be easily transferred over the internet. And here after that we are going to unmarshal, and after that our server can specific function can start executing. So here client is simply client in the application that initiate the gRPC request to the server. Server is the application that receive the gRPC RPC request and respond to it. And marshaling, gRPC is the protobuf. So protobuf require the marshal and unmarshal data that allow the efficient data transfer happen between the actual physical layer. So these are the same components like a client, server, and your RPC runtime environment, yeah, gRPC runtime environment. That's help us to making marshalling and unmarshalling, right? So these are the high level, you can say, architectures of this gRPC API. So whatever the our here gRPC server that's we have, and similarly client can be gRPC client, multiple, maybe a Ruby client, might be Android client, maybe here service also can be any language, maybe C++, .NET, Python, Golang. Server can be any, and our client can be any. So any clients can do gRPC request, means ki proto buff request, and they get the proto buff response here. So that allow us nowadays, notice in the microservice environment, generally our one microservice can build on the maybe different language, different programming language, different maybe Go, Java, .NET, right? In different similarly, client also can be different Ruby client, Android client, because the this gRPC documentation support, like this gRPC frameworks or gRPC API development can be done in a different language. Server can be different language. Maybe both option, both can be same language, Java, or Java, C++, .NET, Go, Ruby, Python, every language, right? So this is a very simplified approach between the inter microservice communication happen. This is more and more preferable choice between the inter microservice communication. These are the not more favorable choice between the front end application or UI going to the call here. These are the example which I am taking. This is the main component between the gRPC API is your about the your protobuf file. The protobuf syntax is a very simple and simple one file that dot a proto file, and we have to specify the syntax of protobuf, and the, because they are the protobuf compiler going to generate classes, the what the package they are going to generate class, and they are the list of services. Here you can say services tag, and this is your class name, and here when hello service, calculate service, whatever the RPC services you want, service 1, service 2, service 3, service 4, service 5, all the CRUD operation, get, update, delete, whatever the services you want, you can just mention your RPC and service name, and here you can mention each service what the request data structure, what the response data structure, means ki what kind of your request format and what kind of response format. So here you can say we cannot going to mention here maybe ID, name, address, whatever thing request parameter you want, what the response would be. So this is define a custom object, a custom message, and this is the what the request message, it is a message, and here also mention the content name, ID, address, and here you can all the data types like string, int, array, they are support, and you can also similar response, what kind of a response. So very nice wrapper, you can say. Here just mention your RPC service name and your request data structure and response data structure, and well defined key what is the request data structure would be, what the data types, and response data structure would be what the number of fields, and each field what the data type, integer, flow testing, everything. So this file protobuf file is a very simple, we can easily any developer can understand, and Golang, Google's provide the your gRPC compiler. Just you compile this protobuf file, and they generate your client stuffs. And the same protobuf file is compiled by your server. They generate the server stuff for them. The server side, server stuff going to implement by the server application, and client stuff going by implement by your client code. Client is just going to invoke this code, and finally the communication between client stuff and server stuff is taken care by your gRPC framework. So from the application developer perspective, this is very simplest way to call any inter microservices. From we have already client code available, let's say I'm going to call simply particular function, look like if someone look the code, they are just calling another local method look like. So there is not you can specify anything. Hey, I'm going to connect the particular IP address, particular port, particular URL, particular API path, get, post. So whenever you are going to make a simple communication client and server by the RPC. They have a lots of the first name the protocol HTTP protocol. Then you can know your complete IP address. Then know your port number. Then know application name. Then you know your particular API, then the request file, everything. So these details are everything now hidden by our gRPC framework runtime environment. gRPC runtime environment simply say you have a client, just client dot call and whatever the local object you can pass it. Now everything is taken care by your gRPC framework. So one thing might be aware ki how our client could know ki where is what is the IP address, what is the service name. So initially there is a your application required one kind of configuration where you can mention your gRPC server and client address, port, and services name. That's the just configure file, and anyone can configure. After that, it will rest of the works about the RPC implementation taken care by your gRPC runtime environment. So these are the basic simple approach that someone going to implement the gRPC API. The first you define your service in the dot protobuf file. Protobuf file. This as we discussed, defining the service. Just you write the RPC, your service name, what are the service name, or API name, and you can express what the kind of input types, what are the kind of input type, input and output data structure. Data structure detail you can mention what the input request name is, whatever that you want. Once you have available your protobuf file, this protobuf file can be shareable to the client and server so that every client and every one know okay, this is a service offered by the particular service. So I will again generate the stub code. Our this stub code is generated by the server, and this stub code are generated by the client as well as. So they are required whenever you compile the code, they can generate the client stub and server stub as well as. So as a server, we are going to just first generate the stub code. Use the protobuf compiler. This is a protobuf compiler. We have a gRPC plugin to generate the stub code for your services. So first, as a service provider, I am going to write this service definition and generate the server stuff, and they are providing giving me some abstract class and interface where I am going to implement my business logic, the particular the stub code generated by the our my specific interface. Just we have write my inter class and just extend the object stub that generated by the code. So after that, we are creating our gRPC server and create the gRPC server and deploy it to particular host on your particular service and particular port. These hosts and ports are configured in the one of your application configuration file. Now, similarly, our gRPC client also get this find this protobuf file. They generate the stub they generate the stuff and they client stuff, and using the client stuff they are going to just call our the specific service specific method look like they are calling the local functioner method. So this is the beauty of gRPC, that from the developer perspective we are not more aware to calling the HTTP, IP address, host, application URL. Everything is now under hood taken care by your gRPC framework. You can make a very simplest way gRPC API communication between inter microservice communication. So lots of frameworks available, I can say, for the gRPC. You can gRPC Java, gRPC Python, gRPC Go, gRPC Node, maybe ASP.NET. Lots of you can language technology we have available. If you want to develop a gRPC API, Java-based framework you can use, or Python-based framework you can use, Go-based framework can use, Node-based framework can use, maybe a .NET-based framework can use to develop the gRPC API. And similarly, gRPC lots of client available Python client, Go client, Java client, .NET client, Ruby clients. So communication happens. So if you for the developing gRPC API, lots of application framework also nowadays available that help us so easily you can just build. So all the gRPC frameworks which are provided by Google, all the you can say latest web application framework provide the dependency. Just you in your application, if you are using the Quarkus framework to build your application, they are just you can include the add the dependency of the gRPC frameworks. Or you are using the Spring Boot application framework, Spring Boot also provide the dependency for the gRPC frameworks. Are you developing API using the Micronaut frameworks? This also provide the dependency for the gRPC. So the famous application frameworks are the language. They are provide the dependency as well as. So if you are going to directly build the gRPC using a basic framework, you can do, or your application are using some inbuilt application framework like Quarkus, Spring Boot, or Micronaut, and other any application framework. Mostly all the application framework also support provided a high level dependency of gRPC API. If you are using the any framework dependency, everything just hide. Just simplest way to inter microservice service communication happen using the help of these application framework. And this is the challenges also how you can perform the testing of these API. Generally, if you develop the REST API like a GET API, you can test from the browser, Postman, similarly here also for the testing this gRPC API, we have a Gulf available, Postman available, SOAP available, JMeter available, Bloom RPC available. You can just these are the tools available. And this tool, hey, you can say, hey, this is a protobuf file. Just import the protobuf file, and whenever you import protobuf file, they know, hey, these are the number of services available. You can just open any request, and these are request parameter, response parameter. Just type the request and share the particular service you are and head, and you are getting the data. So the testing is also very, but the basic rule, whatever the you are developing API, you as a developer, you must try to test it. So this is the somehow these are API are basically highly used in the inter service communication or inter microservice communication instead of your mobile application or front end application directly going to the call gRPC API. So these are the some environment use case where these highly gRPC API are used. Maybe you can talk about the microservice architecture. I very heavily in microservice architecture because the basic concept of microservice architecture is that all your component or your module is deployed in the separate instance, separate services in the different environment. You are building the independent business unity, business capability in the separate microservice. Each separate microservice look like a separate application. They have their own database, they have their own development, test, deployment happen, independent deployment happen, scalability independently happen right now. So due to this scenario, the inter microservice communication for meeting the particular business capability required, where gRPC is widely used between the inter microservice communication. In a real-time application where the multiple component you want to your different modules or service that are on the different machines can we communicate as a real time using the gRPC communication like your gaming, video streaming, financial trading, anything tradings can be real time response. That means your communication between the different remote server, remote machine, remote devices as fast as possible. So gRPC is one of the, you can say, fastest performance in the terms of a remote communication protocol or channel. All the cloud computing systems nowadays are using the gRPC using the cloud computing to enable the communication between the device. All nowadays the IoT devices, generally IoT devices nowadays, lots of going to send data, consume data, and to the send on a particular server. So gRPC API help us to make the IoT device properly communicated to the server, different devices, edge devices, computing devices, microservice devices. So these are inter microservice communication, inter device communication, inter server communication. These gRPC is heavily useful. These are the very high performant system. These are the other benefit you can uh, achieve if you are developing gRPC API for the different device communication. So this is a very high performance. You can say gRPC provide high performance RPC capability, making it suitable for the real time application. So all the real time applications where your response are very fast, very quick. So if your real-time applications are depend on the different machines or server to communicate each other to meet the particular user's requirement, so gRPC API play very critical roles. And sometimes you want to effective data transfer between the particular server, between the computer. So in those scenario also gRPC protocol also used to marshaling unmasked data and allow the efficient data transfer between the devices, between the machines. They are also help us to make scalability, because they are enable to scale your application in different services, and each and every multiple machine and multiple microservice can make effective communication, data exchange, calling happen with a gRPC. And this is also ensure that some level of your security. gRPC provide the built-in security features such as authentication, authorization whenever you are going to. So RPC, gRPC framework runtime environments also ensure that what the data you are transferring from one machine to another machine, that can be under authenticated, authorized, and all the encryption decryptions is already taken care by your framework. You don't need to more worry. These are the additional benefits we can get if we are developing or exposing the gRPC API. Some are the challenges, so lots of challenges. I'm not mention everything, but might be you think about the limited browser support. Look like if you are going to many REST API or GET API, you can access from your browser. Maybe with the Swagger API, Swagger documentation allow you to do lots of communication from browser. But generally, gRPC is not natively supported the browser, which make it challenges to the web application. Directly, any front-end application, UI applications are not directly communicated by the gRPC. They can, but this is very lots of challenges where. And similarly there are some, if you want to proper error message, error handling, because here your machine directly not communicate with another, instead of they are communicating with the your client server at gRPC server, gRPC client. So might be we can face challenges to propagating the error occur the actual our client and side. So sometimes we make a very generic error message or the so that the client can understand what the problem. So these are the limitation about the testings on the browser basis or error handling proper error code. Might be we have to very uh, rig- rigorously define the proper error code so that any customer can easily understand the meaning and descriptions if the particular error occur between the inter microservice communication. And many applications already nowadays are using the gRPC. Google itself, because Google has developed this, so Google itself uses gRPC in the production environment to enable communication between the services. Netflix also uses gRPC enable communication between the microservices. AWS also uses gRPC enable communication between its cloud services. Dropbox uses gRPC enable communication between its services. Many you can say nowadays distributed applications where they have to going to serve the particular client request that required multiple service communication. So here inter microservice communication where the gRPC protocols, yeah, gRPC API very good choice to interaction between the different component, different computer, different services, because these are the gRPC API is enable different machines our program can communicate to each other, and each program can be in a different language, different technology. One is the Java, one is the Python. We have developed our server gRPC API via co-language, and someone can be consumed from the .NET, or can consume from the maybe Python, consume from the other language. So due to the inter-language communication, and they are very standard, everything taken care by your gRPC framework or runtime environment. That awesome choice for the developer. Now there is no any hurdle or challenges faced by the junior engineer or any senior engineer when they are decided I'm going to the call customer microservice, yeah, product microservice, payment microservice. The developer time is very reduced because there is a no hurry. It's look like a simple one method they are going to the call like a local, but internally they are using the gRPC runtime environment. Everything taken care by identify the IP, authentication, authorization, marshaling, unmarshaling, sending to the remote. Everything taken care by your gRPC runtime environments. So you can say these are the very handy point. And nowadays applications are going to many applications where the particular customer business capability is not served by only one service machine or server due to the high traffic, due to the scalability. So you are scaling multiple requests, multiple server, whenever they're in the distributed environment where you want to exchange data between the server, between the services, between the computers. So you need some communication protocol. So gRPC is the one of the choice where you can make gRPC communication between the servers, between the uh, microservices, and that's make a high performance, reliable, scalable, and inbuilt security concerns. You get like encryption, decryption, or authentication. Everything is taken care by this gRPC runtime environments. So hope this information is helpful for you. That's for the day. Thank you.